All right, let's read the problem and get organized with what our givens are. So it's a concave mirror, and that immediately tells us that the focal length is going to be positive. And the problem says that it's 20 centimeters long. So my focal length is positive 20 centimeters. What we're going to be looking for in this problem is the location of the image. So that's DI. And the problem gives us three different parts. So we're going to find DI three times. And we are given object distances. So we are going to identify the variable that is D sub O, and we're going to do parts A, B, and C. So three different object distances. All right, and for each of them, we're going to state if the image is in front or behind the mirror. How we are going to figure that out is based on the sign of DI. If it's positive, it's in front of the mirror, and if it's negative, it will be behind the mirror. Upright or inverted, we're going to figure that one out based on the magnification. If it's positive, it's upright, and if it's negative, it is inverted. And finally, they want us to report the magnification. I'm going to start by sketching my problem here. So I'm drawing the principal axis in and the mirror, and then I am going to label the center of curvature and the focal point. The focal point is at the focal length, which is 20 centimeters away from the mirror. And because the center of curvature is located a distance of R away from the mirror, it will be 2 times 20 centimeters or 40 centimeters. And that is how I can identify that part A has our object directly at the center of curvature, and part B is my object at the focal point, and then part C, my object is closer to the mirror than the focal point. So for this problem, I'm going to put my object at the three different locations that I've shown here, but I'm starting with it at part A, right at the center of curvature. These are the two equations that I will be using to solve this problem. First, we'll use DO and focal length to solve for DI. From this, we can make some conclusions about the image. Because DI is positive, it is in front of the mirror. Now we will use my image and object distances to solve for the magnification. Okay, and this tells me two things. Because the magnitude is 1, it means that the image is the same size as the object. And because it is negative, it means that the image is inverted or upside down. Okay, part B, we're going to use the same equation as we did in part A, only with a new object distance, 20 centimeters. So 1 over DI equals 0. That means that DI equals infinity. And if the image distance is infinitely far away, no image is formed. Okay, part C. Now we have our object very close to the mirror. And if you think back to what we learned in the previous video, we conceptually should know what to expect in terms of our image when our object is very close to a concave mirror. All right, for this one, I find an image distance of negative 20 centimeters. So that negative means that it is behind the mirror and virtual. Let's go ahead and calculate the magnification next. All right, now we have all of the information that we need to describe our image. It is behind the mirror because of that negative sign. That makes it virtual. It is magnified by 2 times, and it is upright because the magnification was positive.